All right, with this video, we're going to be looking at graphs of inverses. So for inverses, remember, we switch the x and y exactly where they are in the equation. So what happens is all of the coordinates also switch their x and y values. So with that being said, when given a graph, the inverse is reflected over the line y equals x. That is because all of the x values become the y values, and all of the y values become the x values. So we trade the x and y values of our whole equation. We can only have an inverse function. This word function is very important if it passes the horizontal line test. Remember, we were talking about one-to-one functions. One-to-one function means the inverse is also a function. So if we have a graph to find the points in the inverse, we can reverse the coordinates. Exactly. So that's what I was saying before. So just looking at these examples, determine whether each function has an inverse function. If it does, state three coordinates that would be on its inverse. So first thing, passes the horizontal line test. Does it pass the horizontal line test? Well, let's see. If I run a horizontal line anywhere on my graph, yeah, it only hits it at one point at any given time. So it looks like it's only 1 point everywhere. So yes, the inverse is a function. I'll just start writing yes. All right, and if it is, state three coordinates that would be on its inverse. So looking at the original function, it looks like we have the point like 2, 4. So 2, 4, that's on the original. We also have 0, -3. We also have, it looks like, let's go there, about -1, -4. It'll be much easier to see on Apex. But for the inverse, the three coordinates that we could write, remember they switched the x and y values. So for an inverse, we could have 4, 2. We could have -3, 0. We could have -4, -1. Remember, you're just switching the x and y values exactly where they are. All right, looking at the next one. So with B here, thinking about the horizontal line test, if I run a horizontal line right there, it touches at 1, 2, 3 separate coordinates. So no, the inverse is not a function. If it passes the horizontal line test, then state three coordinates. So since it's not an inverse function, there's no coordinates to state. That's it. Can't do anything else. Looking at part C, all right, we have something that also does not pass the horizontal line test. So this one is not an inverse function. So you can say no and move on with your life. For part D here, we have to think a little bit harder about this. But just remember, a one-to-one function, there are no repeated x values, so it looks like there's no repeated x values, so we're good there. And there's no repeated y values. There's also no repeated y values, so that's good there. Just remember that f of x equals y, you'll be golden. So to state three coordinates, this is just switching the x and y, so you could have like 12, -2. You could have 10, -1. You could have 8, 0. You could have 6, 1. You could have 4, 2. Remember, the inverse functions just switch the x and y exactly where they are. Has to pass the horizontal line test, and they reflect over the line y equals x. Ta-da! That's really all there is as far as graphing inverse functions, so short, sweet, to the point. All right, so again, as always, email me, let me know what questions you guys have. I look forward to working with you. All right, keep up the good work.
Yeah, I'm working good.